Yeah, hi everyone. This is a video about solving polynomial equations. Actually, it's more about factoring and solving by factoring. So a polynomial is something that looks like this, with x to the power n, so whole number powers, and so we're factoring it and we're solving it to work out what x equals. So most times it's really hard, sometimes it's easy, and that's what we want to talk about, some of those easy cases. There's a few times when it's going to be easy, but there's a few general rules to take into consideration. Always see if you can get out a greatest common factor, highest common factor. Okay, that'll solve you a lot of issues, a lot of time, and make the solving a lot easier. Now we're going to think about if it's got 2 terms, 3 terms, or more than 3 terms. If it's got 2 terms, if it's a difference of 2 squares, you can use this factoring rule to do it. If it's a difference or a sum of 2 cubes, you can use these rules. Okay, so if you know these rules, they'll save you a lot of time. You definitely need to memorize the difference of 2 squares rule. If it's got 3 terms, check that it's a perfect square, or if it's a perfect square. And if it's not a perfect square, check to see if you can factor it like you factor a normal quadratic. If you need to revise factoring quadratics, I've got another video you can look up. If you have more than 4 terms, often there's not a lot you can do, but try factoring by grouping. Yeah, do a pair of pairs, or group a number of terms together and see if there's anything common you can get out. Okay, so we're going to go through examples of all of these, and hopefully that'll help you understand what's going on. So this is a nice quadratic, so this is, hopefully you've had a good go at lots of these recently. The first thing to do with the quadratic with any polynomial is take out the common factor of 3 here, so take that out. Okay, now the way I factor quadratics is the splitting the middle method. Okay, you might know another method, cross method, or a guess and check sort of method, but I like the splitting the middle, so I'll walk you through that. 8 times 15 is 120. Okay, so it's negative 120. What are the factors of negative 120 that add up to 14? Well, it's negative 20 and 6. And then we group these 2 and these 2. So what's common to these 2 is 4x. What's common to these 2 is 3. And then we're left with the same thing in the brackets here, so we can take that out as a factor. So that is my factored quadratic. Okay, so being able to jump from here to here is real important, and it'll help you do a lot of the hardest stuff if you can do this well. If you're struggling with quadratics, go back and review them, have a look at another video. I'll put a link somewhere. Now, here's some more simple factoring. Now, as you look at these, none of these are quadratics, so we're going to think again. The first thing we always do is look for greatest common factor. In this case, 14 and 42, greatest common factor is 7. They got an x in common, and they got a y squared in common. So you take that out the front. Okay. This one, there's no common factors. You can say, oh, 3, 3, 3, but this one doesn't have a 3. So try and group it, these 2 together and these 2 together. And when you do that, look at that. n plus 3 is common to these 2, and n plus 3 is common to these 2. So we can take that out the front. We factored it. This is a special pattern here. This is a difference of 2 squares. 100's a square number, 9's a squared number, m to the 8 is also a squared number. It's m to the 4 squared. So we've got a difference of 2 squares here. So it's 10m to the 4 plus 3, 10m to the 4 minus 3. Okay. And then this one, again, there's nothing, no special pattern here. It's not difference of squares, but there are common factors, so let's do that. And then you can see there's nothing we can do inside the brackets here, so we're done. Okay, we're going to come back to a couple of these a bit later in the video. So that was factoring. Now we're solving. Okay, you say, okay, this power of 4, what do I do? But actually, this is a hidden quadratic. You see the power of 4 here and the power of 2 here. So it's like x squared squared minus 40x squared plus 144. So you can factor this just like you'd factor a quadratic, but instead of having x, you've got x squared. So factors of 144 that add up to negative 40 and negative 4 and negative 36. Okay, from here there's two ways you could go. Using the null factor law or the zero product property, okay, either this one's 0 or that one's 0. Okay, so we got x squared minus 4 equals 0 or x squared minus 36 equals 0. So x squared equals 4 or 36, so x equals plus or minus 2 or plus or minus 6. Alternatively, you could recognize here these are difference of two squares, and you could factor them all out. So, and now using our null factor law, you can get your 4 solutions. By the way, that's something I'll talk about a little bit later in the video. We got x to the power 4, so we got 4 solutions. Could be 4 solutions. By the way, there are the 4 solutions, and it's a nice symmetric pattern, so you know you'll get nice symmetric solutions. Okay, this one is not a polynomial, but it's an interesting thing to look at just quickly. This also is a hidden quadratic. Look, it's the square root of x squared gives you x. So you can factor this just like you'd factor a normal quadratic. I skipped a few steps there, which gives us either of these two things equals 0. Now the square root of x can't be a negative number, so it has to be this answer. So x has got to be 5 on 2 squared, which is 6.25. Okay, that was a bit quick on that one, but I just wanted to show you a different example of a hidden quadratic. These are the ones we factored earlier, and now we can use the same law. Alright, if this, what's the solution over here? I'm looking for what does m equal? Well, one of these things in the brackets has to equal 0 if they multiply to be 0. So m to the 4 has to be negative 3 on 10 or positive 3 on 10. Can't be negative. If you square something, it's always going to be positive, so that can't be. So we take the 4th root of 3 on 10 as an answer. Actually, I made a mistake here. This should be plus or minus. Over here, multiplying two things together to get 0, so one of them's got to be 0, and solving, you do that. Again, this is not really a polynomial, but shows you the interesting idea and concept. Okay, moving on. Last thing I wanted to mention is just if you have an even numbered degree, the power of your polynomial highest power is an even number. It's going to be this U shape or W shape. Okay, so it's going to start up, go down, and then go end up again. Or if its leading coefficient is negative, it'll be the same thing but upside down. If you got an odd numbered degree, it'll be sort of starting down low, wiggling about in the middle, and then finishing up high. Or if it's your first coefficient is negative, it'll go the other direction. What I wanted to show you though is that if you have an even numbered, you could have for example, if you had the power of 4, you can have 4 solutions, 3, 2, 1 or 0. So for example here, if the x-axis was here, you'd have 2 solutions. If it was here, you'd have 1, 2, 3. If this was your x-axis, that would be 1, 2, 3, 4 solutions. here 1, 2, 3, here 1, 2, here 1, here 0. So if you've got an even numbered degree, you can have from 0 up to whatever your degree is, solutions. If it's odd numbered, you can have between whatever your degree is and 1. So if your x-axis is here, you got 1. If it was here, 2 solutions. If it's here, 1, 2, 3. If it's here, 1, 2. If it's here, 1. So even numbered, you've got between 1 and 3. 1 and whatever your degree is, solution. Did I say even? Odd. Odd. Okay, and that has implications for domain and range too. Like with your odd numbered, your domain and range are both all real numbers. With your even numbered degrees, your domain's all real numbered, but your range is from here up. From your minimum up or from your maximum down, if it's the other way around. I hope that's not confusing. I just wanted to show you that. You could have that many real roots. We haven't talked about complex roots in this video, but if you get onto that, there'll always be 4, or there'll always be whatever the degree is, but some of them may be complex. Alright, hope that's helpful. Go back and look at them again, and good luck solving polynomial equations.